Okay guys, so this is a session on how we can build a multi-tier distributed systems using microservices. So we're gonna use Python for this session, and this is the environment what I have. I have a very basic Lenovo laptop, and this is the configuration what I have. And these are the installers which you will be needing for development. And 3 and 4 is not. You can skip these two. And for the first half of the session, I don't think even these are necessary. I'll show you how you can do without it. Okay, having said that, let's actually go with the tiers. So first thing is we're gonna build an application layer, and for this session we're gonna skip the DB part. We can have a server. We'll have a user interface, and we can have a UI styling and client layer. So before we jump into the next part, so what we're gonna do is to summarize everything, we're gonna pick an application or a puzzle, try to solve it, and then we're gonna implement an application around it. So we are gonna do something which is very close to production, but how does it differ from production is we're not gonna build unit tests using any specialized libraries like PyTest or anything. There is no CI/CDs, continuous integration or development. So since there is continuous deployment, since there is no deployment, we do not have any higher environments like UAT prod, none of those. And also, of course, we do not have any code reviewers nor approvers. For this session, we're gonna skip any databases, and we're not gonna build it using any something like TDD or test development or anything. There's no we're not going to use this, and of course there's no candidate test around it. So now let's go step by step. On the first part, we're gonna set up the environment, and then we're gonna gather some requirements, analyze the requirements, and then we're gonna build some unit tests around it. So this is the first step, first part. So let's start with the first step, which is environment setup. So like I said, I don't think you require anything much, so I'm going to show you. So I'm going to start the first part of the development on the cloud console. So let me open Google Cloud. Okay, so while this loads, let's open. Okay, while this open, let's actually gather the requirements. Okay, or let's actually finish up the environment setup. So I'm going to activate Cloud Shell. From there I'm gonna open editor. So this is gonna take a few seconds to load. So let's wait for a couple of seconds over here. Okay, so I've already cloned the Git repo, so these are all the stuffs what I already have here. Okay, so now our environment is there. This comes pre-installed with Python and Git, Python, Git, as well as Docker, the Cloud Shell, Google Cloud. Okay, so let's go over and gather the requirements for our development. So let's actually go to my sites, and I'll go to Cloud Code Wars. So this is a good site for katas. So let's go to practice. I'm going to select Python here. I'm going to select approved progress. I have not completed. Okay, so now, so let's say rank 7, or we'll start with something which is simple. Okay, find screen size. So let's understand the requirement. So Cheesy Cheese Man just got a new monitor. He is happy with it, but he just discovered that his old desktop wallpaper no longer fits. He wants to find a new wallpaper, but does not know which size wallpaper he should be looking for. And alas, he just threw out the new monitors box Luckily, he remembers the width and the aspect ratio of the monitor from when Bob Mortimer sold it to him. Can you help Cheesy out? Given an integer width and the string ratio written as width is to height, output the string dimensions as screen dimensions as a string written as width into height. So let's train again. I already looked into it some time back. Okay, so you are given width and a ratio like this. You have to come up with width into height, this value. So this is not a very difficult kata. So let me actually show you what can be done here. So you are given something like I have not solved this, but I had just taken a look into it. So divided by x is equal to 4 by 3. So what happens is, so x becomes equal to 1024 into 3 divided by 4. So this is the formula that should. So let's try it out over here. I'm gonna just open the, okay, so instead of this, there's two options. Either you can use Python console or you can use anything over here. So let's actually go to our terminal and let's actually, let's have it over here. You can also use a cloud console over here. Like if you can just say Python and you can do all your calculations over here. Either you can do something, or let me, it doesn't matter. So let's say 1024 divided into 3 divided by 4. So 768.0 is the number that we are looking for. Okay, so this number we already have, and this is the number what we got here. Okay, so let's actually start working on it. So let's actually numerator. So I'll just say numerator comma denominator is equal to ratio dot split into this. So this is going to split these two values, and then I'm going to say I have to convert this into int. I'm just checking if there's a better way of doing it. Say num is equal to int of num, and let's say denominator. So let's make it m to n. Denominator is equal to into denominator. Okay, so from here we can actually take the denominator value. What is this? So here we have the numerator and denominator. So we're gonna take the denominator and multiply it with the width and divide it by numerator. So once we have that, we're gonna do this. Okay, so I think this would be a blueprint, and we can start looking into it. So okay, so let's go back to our requirements screen. If I can find it. This is not required, you can go away now. Here it is. So okay, so the environment is set up over here. Environment is not set up. We have the requirements on what needs to be done. Let's finalize the environment now. So okay, so what I'm gonna do is, I usually have a separate folder for each and every application that we're gonna build. So let's pwd ls cd to git repo ls cd to python snippets. Okay, ls. So let's create a directory for the application that we're gonna build now. I'm just gonna say, let's give it any name like screen. Okay, so let's go to the window and say screen size. Okay, cd screen size. Okay, so here we're gonna have create an application folder. Let's say apps cd apps, and we're gonna create screen size.py file. So now, as you can see here, let me show you screen size. So this is the structure. We have screen size, and we have apps, and we have screen size.py. So let's open this file. Let's create the description of the application over here. Okay, and then let's copy tests. Let's always start with tests. So these are the tests. Okay, so replace asserts with plain asserts. Okay, and then because like I said, we're not going to use any specialized libraries because it's much simpler to do this way. Let's replace this with equals. Okay, so now I think we are set. The tests are set, and let's copy the core application. Okay, so now this is done. So now let's actually start with result is equal to width into denominator by numerator. So I'm just thinking, instead of this I can int okay, then let's say return f of format width into so let's give it a proper name here. So here height. Okay, let's say height, HEIGHT, height. Into height. Okay, so let's see if this works for us. Okay, seems all the tests are working, so let's confirm it again. So let's put a print statement here and say done. Okay, things seems to be working fine. So let's put it over here and test it. Okay, things have passed, attempted. Okay, everything passed, submitted. Okay, width into height, blah blah blah. I'm just looking. Okay, most of them are 2 lines, so okay, they are good. Okay, so now we have built the core of this. So what are the next step? So we have set up the environment is done. Requirement gathering we understood, and we understood, and we tried to do a simple thing, and it worked. So unit test, we built the unit test and things worked. So let's actually core is built, testing is done. Okay, let's build a Docker image for this. Okay, so let's test it in Docker. So before that, let's create a Docker file. Where am I? Okay, I'm in a Python CLI. So let's pwd. Okay, let's create a Docker file. Touch Docker file. So Docker file is created. So let's create a Docker run -it minus, you don't require a Docker file for this. I'm just creating just so that I have a note of this. So volume home/apps, working directory is /home/apps, and let's create a port is also not required, so it's just practice 3.11.slim. I hope they have this image, Python, and screen size .py. So this is the Docker command. Copy and let's paste it over here. So I should get done after the, okay, it got executed. Now let's build a Docker file for this. Before I go for, let's go here. So co-logic is done, testing is done, run in Docker is done. Okay, so let's actually create contents for this later when you're doing Flask, or while building API around this. So okay, so these are the steps. Till here you don't require any environment, you just require a browser. So get status pwd cd dot pwd. Okay, git add, git commit -m, let's say screen size, let us say git push. Okay, let me add my email ID and password and get back. So let me type my email ID here. My username, and let me add the password. Okay. Okay, so this went through. So let me actually, okay, so this should be there in my Git repo. So now, having said that, this is solved. So console is done. So this is gone to the Git. So now let's start continue the work on the VS Code. So opening my VS Code here. Let me close the browser. Go close all of this. File, open folder. Let's go to snippets, open folder. Or instead of opening the whole thing, I mean, that's all right. Open terminal. Let me pull the changes that we made. Screen size is here. So where is the screen size? Okay, here it is. Okay, so cd to screen size. Okay, cd to apps. Okay, so now let's open screen size or Docker file. So what are the next steps here? So let's build a Flask. Let's start with Flask today. Let's change this to okay, let's just call it Canary test and do development. So we are here. Let's build a server for this. Okay, so now touch server.py. Okay, so it is not loaded. I might have to refresh this. Okay, so let's start. So from Flask import Flask command request from what else, Flask underscore CORS import course, and then what else, let's actually do app is equal to Flask. Let's say, and also soft app, and start with app dot route. So this is a library which is I've already installed it. You might have to install if you do not have, and also you need to install Flask underscore CORS here. It's a cross-origin resource sharing library. So anyway, so let's do post. So first step, post, and then definition of, let's just say function, and then so let's say data is equal to request dot JSON of data. So I'm just doing a simple test to see if the server is running, and then we can start on the implementation of the logic. So let's say return, let's say working, and let me print the data as well here for our reference. Let me close this inside the parenthesis. Okay, so let's say underscore name app dot run post is equal to, let's say 0.0.0.0 comma port is equal to, I usually use 5000. Let's say debug is equal to true. I don't want to restart every single time. Okay, so now let's actually do some testing before we do implementation. So this is what we're doing now. Okay, this has started. I also have a Thunder client to test the APIs. So let's say if I have something called as data over here, and make sure you have the port number and endpoint. So, and let's say hi, okay, and send it. So yeah, so this is the exact thing that we are looking for. It is working. So let's, and we have the data as well. So Control C. Now let's start the development of the application from screen size, import screen height, find screen height. Okay, now so let's design how we're gonna send the data. So we have data over here, and if you look at the input, so we have two inputs, one is a string and one is this. So let's send it as width and ratio. So let's say here, so this would be width and this would be ratio. So this should be a string, sorry, an integer like this. Okay, so this is what we are sending. So let's pass it on to screen size. So what we're gonna do is we're gonna get width and ratio in JSON. Okay, so this becomes width, and we're gonna call it width, and we're gonna copy this, paste it over here, and this is ratio. So now what we're gonna do is we're gonna pass it on to find screen size. Width, oops. Let me copy this, width and ratio, result, and let me pass the result back. Okay, I'm just saving it. So let's run the server now. Okay, so now server is running. Let's send. So here you have the result. Send it again. Yep. So it's just a plain JSON format from headers, and this is the body which I'm sending. So things are looking good. So let's kill the server and let's remove the debug part. So the server is working fine, and it's able to communicate with the application layer. It's able to give me the result. Okay, so now the development is done on the server side. So let's create a Docker file for the same. So I'm gonna open the Docker file. So let's so like I mentioned, going back to the server, these are the libraries which are required. So we need to install these libraries on Docker environment. So we need to have requirements file. So let's create requirements file here. I'm actually inside the root directory, so let me navigate. Screen size, ls cd apps, and let me touch requirements ents.txt. Hopefully I can refresh here now. Refresh requirements. So I need Flask and Flask course. Okay, now let's build that from Python 3.11 minus slim. Copy current working directory into home / apps rkdir /home / apps, and run pip 3 -r install -r require ments.txt, and then command python server.py. Okay, so this is our Docker file that we have created so far. So let's test the Docker file and see if it's working for us. So let's say, and let me put the command right over here. Docker build -t screen size version 1. Okay, let's run it. And guys, like I mentioned, Docker is I've already installed Docker over here. Okay, Docker images. So we have screen size image over here, so let's have another command. Docker run -p, let's port map it to 5000. Okay, and let's run it detached -d, and image ID, of course, paste. Okay, so let's, okay, as you can see it's working fine. Maybe we can try for another test value, which is over here, which is this 16:9. Okay, so let's paste this over here and say 16:9. 16:9. Okay, seems things are working fine. Docker ps -a. So let's kill the Docker container here. Docker stop. Come on. Okay. Docker kill. Okay, there's some issue, so let me actually exec into a disaggregate minus I bash. Maybe I'm missing something. Exec minus. Okay. So okay. Docker ps minus exited. Docker system. So let's remove all the dangling images and stuff. Okay. Now, so what have we done so far? So environment setup, requirement gathering, unit testing is done. So these things are done. Docker file is done and it's tested. So now let's build the user interface for this. So let's actually go back, close this one, and let's create another folder. Let's actually create a separate folder for the UI. So cd .. mkdir templates touch index.html. So okay, so let's move index.html into templates. Okay, so now let's build a simple UI. So here, if you look at this code, it actually takes two inputs. So let's take these two inputs. So you need two fields and a button and maybe a result field. So let's say text area. Let's copy this text area thrice and let's say button. Okay, now let's say numerator so this is width and ratio, right? So let's say width and ratio. I'm just giving a label over here, width and ratio, and let's say result, and let's call this as a button to trigger. So let's break this vi. BR break. Okay, so break twice, let's break twice. Okay, so let's see how it looks. Okay, so this is how it looks. So let's make it a bit better here. We don't require all of this, nor this, nor this. Let's save it. Okay, width, ratio, result, fine. And what else? Yeah, for now it looks right. So let's give it say 1, 2 and 3 and with the same name as 1, 2 and 3. Sorry, 3. And let's give this as 4. Okay. So UI is done. So now let's start with the client. So let's create touch script.js. Screen size, so move script to templates. So we are keeping all the application layer in one folder and the UI based layer in a different folder. So what I meant is, so this will be in a different folder and this would be in a different folder. So HTML index is done. So let's start with script.js. So let's actually server templates script.js. Okay, so async function, let's say fn of, okay, let's say what are the two variables over here, what we get, width and ratio, right? Okay, width, ratio, script.js, the syntax. Document dot get element by id 1 dot value, the same over here, 2, and then once we have this, let's build a payload. Payload is equal to method is equal to post post and h headers is equal to, let's copy headers from here. From Thunderbird, Thunder client, sorry. Headers, content type. Application notice. Let's change this, and then body equal to colon. JSON dot stringify. Width of width, comma, ratio of ratio. One thing if you notice is that the value what you get over here is a string, so we might have to convert this into integers. So let's actually come to our server and convert the width, or you can either do it over here or you can do it in the code, which is here. Screen servers, 1 second. Let's actually open the proper folder here. Screen size. Save it. Okay. Now open the folder. Snippet, screen size. Okay, so now this is open, looks much cleaner now. Let's go to server and let's convert, not the server, the screen size. So width, let's convert this into integer, just in case, or you can just test it. Things are working fine. Yep, things are working fine. So now let's go back to our, okay, the reason why I did was the value, the width might be a string over here once you receive it, so I'm just converting that into integer. Okay, so now let's actually say response is equal to await fetch URL is equal to, what's the URL? This is the URL, and let's payload and let's say result is equal to await response dot text. Okay, and then return result. So let's console dot log width. Okay, console dot log dot. So I just want to make sure if it's able to communicate properly. Now, so this is done. So now what we have to do is we have to integrate this with the HTML code. So let's come here, go to head, and then say script source script.js, and say click is equal to fn. Okay, so once you click that, you do this, and yeah. Okay, so now let's start the server and see if things are working fine. Let's open the operations list. So we are still here. Okay, so now let's start the server and do testing. Where is my server? Here it is. Okay, so now let's open the HTML here, refresh. Let's close this, open the HTML here, go live. Okay, this has opened. So now let's go to the tests, which was here, and give the values, which is 1024 is the width, and 4:3. Before we do anything, let's open the console. Yeah, and we don't really require the entire screen over here. Console. Click. Okay, fine. Okay, basically what happened was we are not getting the results. So that's because we haven't linked it. So anyway, so link the result ID to the results of the script. So instead of sending this, let's say result is equal to document dot get element by ID of, let's say, 3 x, and let's delete this. This should be reverse. Dot value is equal to, oops, so yeah, sorry, so I'm taking this and dumping it there. So yeah, but wait a minute, 1 second. Okay, so this is right. Okay, so now let's actually restart this. Oops, sorry. Let's go to the test, copy this value again, and let's actually make this a bit smaller. Disposing, let's start again. Width is such, and let's put a screen size. Okay, here you go, things are working fine. So we are built an application which is able to communicate with the Python server. Anyway, so let's stop this and go to html.index and let's open this. So index script is working fine. Now let's start with style.css. So let's say link css style sheet. Okay, so now let's create the style sheet. cd templates touch.css. So for styles, let's do some animations or some sort. I'm just looking for that HTML. Where did it go? Oops. Here you go. Okay, so let's do some animations on the button. For that, I'm gonna go to my personal site, which is Animestia. What is the name of that? I'm just checking my sites. Util, where do I have it? IDE. Oh, okay, HTML. Here you go. Animista. Okay. Let's do some attention. Okay, this is fine. Let's grab the code, copy class. All you have to do is go to your CSS file, paste it, and then again paste the next content, which is copy frames. Paste it over here. Control S. Take this vibrate vibrate one, sorry. Go to index. This is already linked, so let's say class. Oops. Let's save it. Let's go to the document. Here you go. So yeah, we did add an animation over here, and index of HTML is working fine, script is fine, and style.css is fine. I mean, if you can beautify this, let's beautify this. So I'm gonna go to IDE, and then let's go to my sites, HTML. Let's go to this. Let's add a simple UI for this. I mean, make it a bit better. Okay, so let's copy this and paste it on the head. Yep, here you go. So this is how our UI looks now, much cleaner than before. Okay, so that's that. Now let's build a Docker file on top of this and deploy this. Now to build a Docker file for this one, let's create a Docker file. So I'm going to this again. So touch Docker file. Okay, so once you've done this, so let's say nginx from nginx copy current working directory into user slash html slash user slash, I think it's nginx slash html. So let's confirm this from the Docker. Say Docker nginx. Okay, it's users share nginx html. So control S. So again it's the same thing, so let's say docker build -t, let's say html version 1 dot. Okay, so let's try both of these things together, or what do you say? Let's test this out. Okay, docker, let's copy paste this. Nginx is, do I see an issue over here? Okay, and basically I have to run docker run -t -port 8080 to 80. So let me confirm this as well. 8080 to 80. Okay, port mapping, and then the ID. So let's start building this. Okay, so docker images. Okay, now take this image ID. Let me run this. Okay. Okay, so let's actually go to the port with the local host 8080. Okay, here you go. So the docker image is working fine. Control C. Oh man. Okay, let me kill this. Docker ps -a, docker exec -it, and this is the container name. Let me bash it first. Okay, docker system prune. Okay, so now so far so good. So the HTML is working fine and the application is working fine. Let's build a Docker compose file, which is here. So this is a single file for which houses both of these builds. So let's say touch compose dot yml. Version 3 services, let's say app build apps slash star ports. Let's map it to 5000 to 5000. Yeah, that's it, I guess. So now let's go to HTML build templates slash ports. Let's map it to 8080 to 80. Okay. So now let's docker hyphen compose up. Oh, I should have run the detached. Nonetheless, it's alright. This is the container name is already in the container. Okay, you need to remove the container refresh. Okay. Docker ps fancy. Let's remove all of this image. And yeah, I think this should be it. Now let's try it again. This time let's run it detached. Docker compose. Let's remove this. Now start the container. Docker compose up. What is that? I don't understand. Docker images. I just removed it. Nginx. Okay, let's do one thing. Docker ps fancy. Docker paste. Docker images. Docker let's remove this as well. Let me fix this and get back. Okay guys, I believe it happens only with Docker Compose. So let's continue. Okay, so I believe the recording is still there. So anyways, okay, so let's park the Docker Compose for now. Okay, so let's continue from all of this. Cancel, let me save this as well. Now let me actually start Kubernetes cluster. So we are here. This one didn't go well as planned, but there's some other issue, but I think this should go fine. Anyway, so let's start the Docker container. So let's go cd and have the certain commands, programming and cat minikube. Okay, start minikube here. It's gonna take a bit. Okay. Come on. Okay, what I'm gonna do is let me get the environment up and then we can get back. Okay, so now I believe the environment is up, the cluster is up. So let's check docker ps load. Let's see docker images. Okay, here I can see all the Kubernetes related images, so it's up. So now let's navigate to the folder. Let's ls cd python snippets, cd screen size ls. Okay, cd let's apps. Let's build the file docker build -t. Let's say server version 1 dot. Okay guys, just reminding, so we are in the deployment process. I'm creating images of this so that I can deploy it in the Kubernetes cluster. Now the image is built. Docker vectl create deployment. Let's say server version 1. Create deployment server and image is equal to HTML. Okay, sorry again, I'm missing the switch. Okay, KUBECTL port forward, port hyphen forward. I think I have to do expose first. Expose deployment. kubectl expose deployment port is equal to 5000. Resources were not provided. Okay, so let me actually see. I think I'm doing the commands are not right, so let me actually go and get the commands, right commands. Expose deployment port. Okay, it's just 5000. Fine. Okay, it says resources were provided but no name was specified. kubectl expose deployment. Expose deployment subset port. Okay, I'm actually missing the server, sorry. Which deployment? The server. Okay, so now let's port forward it. KUBECTL port forward, and again what's the syntax here? Okay, svc hyphen server, and then 5000. Okay, so this is done. So ls cd dot, let's go to templates. Now let's come here and do a deployment on this UI. So cd html ls cd templates. Okay, so let's copy this. Let's build the image first. Docker build -t html version 1. Okay. Okay, so now let's copy this, create deployment, just change the HTML server to HTML. Okay, oops, sorry, this is the wrong HTML hyphen image is equal to, okay. Oh my god, so HTML, there's no space here, I guess. Okay, this is done. So now kubectl expose deployment. So this one, let me confirm the port numbers for here. Okay, 8082. It's expose 80. Okay, exposed, and now let's actually run this port map 80 to 8080. Okay, so now let's actually kubectl get deployments, just see if, okay, both are up. So now let's go to localhost 8080. Awesome. As you can see, things are working fine. You can test it. So I forget the height and width again, which is here 1024 and 4:3. Awesome. Control C. Okay guys, so as you can see, this is the complete video on how you can develop a multi-tiered distributed applications based on microservices. And yep, I think that would be it. Thank you so much. Take care. Bye.